Pause for just a moment. Don't scroll. Don't treat this as an ordinary video, because what you are about to hear and see are not just rocks, not just random stones scattered across a distant planet. These are shapes, forms, structures that make the human mind stop and question reality itself. This is Mars, a cold, silent world, a planet with no cities, no forests, no visible life. And yet, some rocks look carved, some appear carefully placed, some resemble walls, blocks, or ruins, almost as if someone once shaped them. The real question is not why these rocks look strange. The real question is this just coincidence? Or are we looking at something more? Like this video, subscribe to All About Mars Surface, and share it with someone who loves space mysteries. Your support helps us keep uncovering the secrets written not on the surface, but deep beneath it. This is All About Mars Surface, and this story is only just beginning. Before we jump to conclusions, we must accept one uncomfortable truth. The human brain is designed to recognize patterns that it searches for meaning, even where none may exist. We see faces in clouds, animals in mountain shadows, familiar shapes on the surface of the moon. Science calls this phenomenon pareidolia, the tendency to see meaningful patterns in random objects. So we must ask ourselves honestly, are Mars rocks simply another illusion created by our own minds? Or is Mars different? NASA's rovers, Curiosity and Perseverance, have sent back thousands of high-resolution images from the Martian surface. And among those images are formations that shocked not only the public, but scientists as well. Rocks with straight edges, sharp, right-angled corners, layered structures that resemble bricks, circular holes that look drilled rather than eroded. Some formations resemble broken walls. Others look like stair steps. Some appear stacked, almost intentionally. The question becomes unavoidable. We see similar formations. How does nature create shapes that look designed? According to scientists, Mars once experienced flowing water billions of years ago. Yet they are completely natural. It went through intense volcanic activity. Argue that most Martian rock temperature changes can be explained through geology alone. But here's where things can crack rocks into straight lines. Some structures, they can create layers, fit these explanations, and sharp edges. Their angles are too precise. Their placement doesn't seem random. They stand apart from the surrounding terrain. And perhaps most importantly, NASA often uses careful language. They say the formations are likely geological, but likely does not mean confirmed. That single word leaves room for uncertainty. Are we seeing the full picture? Or are some answers still missing? Many scientists agree on one undeniable fact. Mars was once very different. It had liquid water, a thicker atmosphere, conditions that may have supported life. If that is true, then we must ask a difficult question. Is the possibility of ancient Martian life truly zero? This is not about selling alien fantasies. This is not about science fiction. This is about curiosity. Because every major discovery in human history began as a question people were afraid to ask. What seems impossible today often becomes tomorrow's accepted truth. So what is the reality? Most Mars rocks are almost certainly the result of natural processes. But some shapes, some patterns, still challenge our understanding. Science does not advance through denial. It advances through curiosity. And Mars remains a planet full of unanswered questions. Now I want to ask you, do you believe these shapes are just coincidence? Or are we closer than ever to uncovering a deeper truth? A red planet, and a story written across billions of years. Welcome to All About Mars Surface. This is Mars Surface, and this chapter begins with a question that refuses to stay silent. How did a world once shaped by water become the frozen desert we see today? Today's episode explores the changing climate of Mars, a planet that now appears cold, dry, and lifeless, yet still carries unmistakable evidence of a dramatically different past. The surface of Mars is not just rock and dust. It is a record, a timeline carved by atmosphere, water, and time itself. Long ago, Mars was not the hostile world we imagine today. Billions of years in the past, the planet was wrapped in a much thicker atmosphere, dominated by carbon dioxide and enriched with nitrogen and water vapor. This atmospheric shield trapped heat, keeping surface temperatures warm enough for liquid water to exist freely. Water did not hide underground. It moved openly. Rivers cut through vast plains. Lakes filled deep impact craters. Rain may have fallen during warmer eras. These were not brief moments. The Martian surface tells us this environment lasted long enough to reshape the planet. Even now, Mars preserves the fingerprints of those ancient climates. Valley networks stretch across the terrain. Dry riverbeds wind through empty basins. Delta structures fan out where water once slowed and spread. These formations are not accidental. Their shapes mirror water-formed landscapes on Earth. They show erosion, sediment layering, and sustained flow over long periods. Such features could only exist under a climate capable of supporting stable liquid water for extended time spans. But Mars did not remain this way. A major turning point came with the loss of its global magnetic field. Early Mars likely possessed a molten core that generated a magnetic shield similar to Earth's. This invisible barrier once protected the atmosphere from the relentless force of the solar wind. When the magnetic field weakened and eventually vanished, Mars was left exposed. The sun began to strip the planet bare. Charged particles slowly tore away the upper layers of the atmosphere. As the atmosphere thinned, surface pressure collapsed. Liquid water could no longer survive. It froze, evaporated, or escaped into space. Rivers slowed to a stop. Lakes vanished. What remained either sank underground or locked itself into ice beneath the soil and at the poles. This transformation was not sudden. Mars experienced long cycles of change, periods of warming followed by deep cooling. Massive volcanic eruptions once released gases that briefly thickened the atmosphere and raised temperatures. When volcanic activity declined, the planet cooled again. These repeating cycles built layered deposits of ice, dust, and rock that still exist today. Nowhere is this history clearer than at the Martian poles. The polar ice caps are stacked in layers like the rings of a tree. Water ice and frozen carbon dioxide record shifts in temperature, pressure, and dust levels across millions of years. By reading these layers, scientists reconstruct Mars's climate history with remarkable precision. Mars's orbit also plays a critical role. Its axis is tilted much like Earth's, creating seasons, but its elliptical orbit makes those seasons uneven. Over long time scales, the tilt itself changes far more dramatically than Earth's. These variations force ice to migrate across the planet. At times, ice moved toward the equator. At other times, it retreated back to the poles. These shifts reshape temperatures, wind patterns, and erosion processes. Buried glaciers beneath today's dry surface reveal that ice once flowed across regions now stripped and barren. Dust adds another layer to Mars's climate story. Fine, iron-rich particles cover much of the planet and easily rise into the atmosphere. Global dust storms can engulf Mars entirely, blocking sunlight for months. These storms disrupt temperature balance and heat circulation in ways unlike anything on Earth. And unlike Earth, Mars has no oceans to stabilize its climate. Without vast bodies of water to store and release heat, temperature swings on Mars are extreme. Days near the equator may feel relatively mild, while nights plunge into deep freezing. Seasonal changes are stronger. Weather patterns are fragile. Yet Mars is not frozen in time. Even today, subtle climate activity continues. Frost forms and vanishes with the seasons. Polar ice grows and shrinks each year. Carbon dioxide freezes onto the poles during winter and returns to the atmosphere during summer, causing measurable global pressure changes. Winds reshape dunes and transport dust across entire continents. Mars is quiet, but it is not dead. Understanding Mars's climate is essential to understanding its geology. Many rock formations only make sense when viewed through past environmental conditions. Clay minerals reveal long-lasting water. Sulfates point to evaporation and drying. Each mineral marks a different chapter in the planet's climate evolution. Climate change on Mars also shapes the search for life. If life ever existed here, it would have depended on stable water and energy. The most habitable eras likely occurred during warmer, wetter periods. As conditions deteriorated, any life would have needed to adapt, move underground, or disappear. Subsurface environments may have offered protection, shielded from radiation, temperature extremes, and atmospheric loss. These hidden regions are now among the most important targets for future exploration. For future human missions, Mars's climate is more than science. It is survival. Dust storms, radiation, temperature extremes, and long-term atmospheric behavior will determine where humans can land, live, and extract resources like water ice. Mars delivers a powerful lesson. It shows how the loss of a magnetic field and atmosphere can transform an entire world. It reminds us that climate is not permanent. It is shaped by deep planetary forces over time. The red planet stands as a record of water lost, air stripped away, and temperatures driven to extremes. But Mars is not only a warning, it is also a guide. By studying its climate history, scientists gain insight into Earth's past and possible future. The same physical laws govern both worlds, linking their stories across space. Mars continues to evolve. Its ice still moves. Its atmosphere still flows. Every season adds another line to its long, silent record. All About Mars' surface will continue following these changes, exploring how time reshapes planets and how Mars preserves its history in dust, ice, and stone. Share your thoughts in the comments. Like this video. Subscribe to All About Mars Space.